How's it going, everyone? It's the weekend, and get some time to work on this plugin we were working on last week. So I think we're gonna jump back in. Let me switch over to the desktop view and get things moving. So if you all remember last week, we finally figured out how to build a plugin. The few things that ended up being an issue was I was running the stable version of Binary Ninja, but tagging to the dev version of the API, which meant that we were missing a couple symbols when we got to the link point. And so that's all been resolved. I'm running the dev channel now, and we can build it on here. I need to figure out exactly how to tie the version of the API that we bring in to something that runs unstable. Otherwise, we're basically going to be chasing dev versions, which is kind of a shitty situation for anyone who's not running it. But something we can worry about in the future. The other thing we found out is that we need to use the headless feature flag, and this has to do with some of the linking stuff that's done. I don't quite understand all the choices being made around the linking. I especially don't know anything about linking on Windows, and so that's kind of been a hassle just to kind of figure out like what's going on. But effectively, let me see if I can pull up the code. It would be in here. So we saw, I think it's in maybe here. One of these the build.rs files basically has all of these linking options for like Linux. There's a Mac OS one and some. I think this is what ends up falling through for Windows. But basically, it tells it like what to link against, and if you don't use headless here for whatever reason, it doesn't work. There's been discussion in the channel on the REST API about whether some of this stuff can get removed. It seems like it's something that it can, but it's not really clear what's needed and what's not. And I don't know enough about linking on Windows to like make some of these changes without potentially breaking something. And there's not really an easy way to do continuous integration and testing against all the supported platforms, which I'm a little afraid of because I don't really have an easy way to like spin this all up on Windows, Linux, and Mac OS and test it right now. So I don't really know what the strategy is for doing this, but I think in the next couple of weeks I'm going to start putting together some patches for the REST API. We also figured out kind of like how all of the architecture stuff worked here and why the associated types are being used. It seems like some of that might end up going away. All the sizes here are apparently also in bytes, which is good. That's what we expected it to be, but we weren't sure if it was based on bytes or words. And I think IDA uses it based on the word size, which ends up causing problems for architectures like this. It ends up like not being able to find strings, which is really frustrating. So we got to the point where we can load a module. All that's needed effectively is two functions right now. This one, which is the core plugin init. This is how Binary Ninja ends up initializing the plugin, doing any setup that's required. In this case, we're returning true, which just says that the plugin successfully loaded, and loading up the logger, which is basically a wrapper for the logging functionality that's built into Binary Ninja. So I think you can see here, this is something that we printed as it was loaded, and like right here is us loading our plugin. So that's good. We're going to want this. And then the other thing that we need to do is we need to define this core plugin API version. And the reason we need to do this is because for whatever reason, while this does exist and is something that the Rust library should provide us, it's currently not when you build it headless. I would assume because a headless plugin, something that can run outside of Binary Ninja, presumably wouldn't need this function because Binary Ninja isn't loading it. This is like loading the Binary Ninja library effectively and running code that it has in it. So that needs to get fixed. And I don't know enough about the linker to know like what the correct solution is here. But I'm hoping over the next couple of weeks we'll get that kind of sorted out. For now, this is fine and this works, and we can. What does this return? Is it? I always forget. Fine. Take me to the declaration. Oh, that's why. Because I have a semicolon there, so it's returning nothing. So the big thing that we want to get done today is see if we can get the architecture to be registered. That's one of the things that you would do in here is before you return true, you register the architecture. So you say, the msp430 architecture, like this plugin provides that. In order to do that, we need to do two things. We need to implement the flag type, which has a few traits we have to implement, which has some more complicated associated types that we saw. And then we also need to finish implementing the architecture struct. And for most of this, we can stub it out. It's not really necessary right now. As long as the functions are implemented for the trait, the methods implemented for the trait, we can register it, and we'll at least be able to go into Binary Ninja and see yep, msp430 is registered. We have this. It just won't do anything. So my hope is that we'll be able to get this done today, and then the next session we can start actually implementing some of the tokenization. The way that Binary Ninja works is that one of these plugins will you decode instructions to add an address, and then you provide a token string, which is I don't know what all the different tokens are. They're defined as what you can provide it, but it's an opcode and then your operand and some other stuff. And so it's each individual piece broken out as tokens rather than a string of text or something. And that's it seems to work pretty well. So basically what we're going to end up doing is all of the code we wrote for printing in here in our disassembler. So I can find a good example of that. Basically all of this code that we wrote for this, we're probably going to implement our own trait, and that trait is going to be we'll implement the from trait, and we'll just do a from to a token stream, whatever the token stream is expected to be, and it will basically do that same logic, and we'll just turn an individual instruction into a token stream, and that should be pretty simple and be a pretty easy way to do it. And yeah, so the big thing we have to go right now is the flags. So I'm gonna break open. I think we had a few things we were looking at. The example that we had was this, and I don't think that, let's see. So yeah, we have to implement the type flag, flag right, flag class, and flag group. And we'll see up here there's associated types for all of these. Actually, if we go back to architecture real quick, we can see that. Let's see here. Where are we? So these are all the traits. Yeah, here. So these are the associated types that we have to implement, and the way they're done here is they're all of these traits are implemented on one type, which is flag. I kind of assume we'll be able to do that. There's no reason for us not to be able to. We'll probably end up using this same implementation, and then if it doesn't work, we can go from there. But it seems like pretty straightforward, and it might be the way to go. So here's all the register stuff. And we need flag class. Actually, so impl binary ninja architecture flag, and we gotta implement all these methods. Oh. Okay. So we need to we're gonna do that, and then we have to do name role. I wonder if we can like have this auto populate us like all of the method like stubs. Is that a thing it will do? Generate. Yeah. Sweet. Okay. Perfect. That's interesting. It's supposed to return a oh, but it doesn't know what flag roll is. And debug clone. It can probably be copy. That seems fine. We're also gonna have to implement, was it flag right? So he need to do it on all of them? Yeah. Okay, so yeah, flag right, flag group, okay. Flag class. Again, like I hope a lot of these associated types go away. They make it a real pain to build some of this stuff. Just alt insert. Where is the insert key on this keyboard? Does it not have one? Yeah, it doesn't look like it has one, maybe? Okay. Sure. Cool. Okay. And what is this flag class? Does it have associated? Why is this not happy? So it needs to be partially Q at least. trait bound. It's not hash. Can you derive hash? What was done up here? Yeah, you can derive hash. Okay. Does that make it better? Okay, so we need EQ as well. All right. So flag group. Oops. Don't need that. What is this flag group? So I don't know what flag condition is here. Okay, so it's just something that we get. It's brought in. Perfect. Okay. Don't need that. And then we have one more we need to implement. Texture. We have flag group, flag class, flag. We need flag right. And generate all of that. Is this a flag condition? Or a flag right would be? That's interesting. So let's use of unstable library feature allocator API. I don't need allocator API. Get rid of that. Yeah. So this is all stubbed out here. I don't know that we had to stub things out when we actually build this. Dwarf may not actually have flags, but the msp430 definitely does. Associated type flag right not found for self. What is this? Flags written. Flag type. Interesting. So why did this fail? Cannot find flag roll. Did I not implement flag roll? Oh, do I just need to bring it in? Okay, so this builds. Let's go ahead and uncomment all this. And let's add in our other associated types. You know, I think we can just do generate, and it will generate the remaining stuff that we don't have. Yeah, perfect. Okay. So there's no asref implementation, so we're gonna have to fix that. That's interesting. It didn't pre-populate this with unimplemented. Oops. Oh, hey everyone. I have not been paying attention to the chat at all. But Jordan, thank you. That is very helpful. Yeah, so I figured out that part of the API stuff. I need to basically figure out like what is allowed to change on the rest stuff and what's not. I'm not really clear like what the roadmap is, and so my hope is that basically figuring out all of that will make it somewhat easier to go in and like just clean up the stuff that everyone wants to change, and hopefully get to the point where it's pretty stable and there's documentation, and doing this the next time is significantly simpler. So I think we're basically okay doing this, but probably as soon as we load this plugin into Binary Ninja, things are probably going to crash. Either I don't know if a plugin takes down Binary Ninja or not. I guess we'll find that out. But these all panic whenever you hit one of these. But it makes it so that you don't have to ever actually return something. Because we don't have real values yet that we need to return. I think basically as long as we don't disassemble anything, we're okay. I guess that's not too bad. Yeah, so the last thing we need to do here is we need to implement the ASREF core architecture. Yeah. So it looks like all that's done here is it returns self-handle, which I guess handle is a core architecture. What does the dwarf one use? Because I assume whatever it uses, we can also use. Custom architecture handle self. And so this is some kind of type. Let's see if we can go to the definition of it. I think it's basically a marker type. Oh, no, give me the actual, this. Oh, I don't know what this is doing. So, it's... This is like a roundabout way to make customer. Yeah, I'm not sure what the handle is doing. What this is, like why this is here. But yeah, I mean we can go implement the ASREF. That seems like it's pretty straightforward. Core architecture. Yep. And this is just self-handle. And so that's it. What else is missing? ASREF core architecture. No, it's implemented. Right? A whole bunch of stuff here. These are not correct because they're associated types, I think. Is it self? I think this is the correct way to do that. And then specify the associated types. Did we import architecture? We did. Okay, so that's part of the problem. Architecture. And then unresolved reference to architecture. We defined it. It's right here. Oh. Actually, that's fine because it's msp430, not architecture. Expected a core architecture and found a handle. Interesting. Why? Oh, I'm calling it. And then method, not a field. Where is handleify? Oh, that's right. So did I do the wrong one? What is... That's interesting. What is... Okay, so there's a handle that goes to core architecture and then custom. Oh, that's such a weird like convention, but okay. So this is a core architecture and then custom. And then this ends up returning custom handle, which is correct. And this returns handle. Let's get rid of some of these that we're not using. I don't know why it's not instruction text token. Sure, okay. Flag condition. What's the instruction container here? This is a vec of that. That's fine. We'll already have all the implementations I think we need of that. Instruction text token. No method name len found for enum. Okay. Why don't we have len? We defined that for instruction, didn't we? That's interesting. too. We just need to, we didn't define it at the top level here. Which means we have to do that. Impl instruction. Or use size, I think. Complaining. What did these return? Yeah, that's fine. Closing delimiter. Is it too many? Yeah. Expected one of what? Should be fine. So why is that not okay? Oh, there's no match. That would do it. So basically all we're doing here is making the instruction type respond, have a method for length, which gives it the total length in bytes of the instruction. And this is needed by Binary Ninja, so it knows like where one instruction starts and one instruction stops. So it knows how far to go into the byte stream of machine code to give it like the next instruction to decode. And we implemented the length functionality for all these specific instruction types, but we didn't do it at the top level here, and so it can't delegate down to it. Wish there was like a little easier way to do this. Like there's probably some like macro magic we could do, but off the top of my head, I don't know what that is yet, and not a big deal. We can always clean it up later. I mean, this thing's already gone through some refactoring at this point. what's another pass over it? But we're almost most of the way through here, and then once we're done with this, the length instruction should work, and I think that error will be fixed, and then we can go start working on getting the architecture registered with Binary Ninja. Like I said, it's not going to do anything yet, but it will let us like verify that we're loading. It will let us verify that it's an option in the dropdown, and like that's the important part. Once we do that, we can start going and implementing the individual pieces of functionality. And we'll see how bad it is. All right. We'll just run a cargo test here. Red eye does not have. Interesting. Good job. We didn't do that. Yeah. All right. Pub function self. This is just 2, I believe. All right, cool. Associated function len is never called. That's a problem because this needs to be pub, and then that should go away. Yep, all right, there we go. Let's switch back over to here. That should now be fixed. Can't leak private type. That's an easy fix too. We just need to make the flag type public. And register is the same. Oh, come on. There. Okay, it builds. Yeah, I mean, there's probably like a Vim macro that would have worked, but it was faster, I think, just to do that manually. So this builds. We're gonna get all these warnings about unused variables. I don't care about those for right now. What I do care about is getting us registered. So register. There is a method that we're going to need here. Actually, it's probably going to be in here. So this is it. Architecture, register architecture. That's what we want to do. So we are going to do name is, what is S? S is a BN stir compatible, so I think this is just a string basically, msp430. F is a func1. Do we just pass in? Okay, so yeah, it's a oh, this is the wrong, it's here. Basically this is just a closure, custom. And then, so this should just build now, and we should be able to like load this into Binary Ninja. Cool. So we need to get back to where this is. This is right. All right, and then we're gonna copy. Oh, do I have this on my buffer? Yeah. Because okay, yeah, I gotta kill this. But I can do that, and then. Presumably this will load. Or it's crashing, which is probably the case. Is there a debug log somewhere? Do we get a debug log? Where is... So it's not in here. It could be in app data. He said roaming or local. Okay, so that's not helpful. I wonder if we can start Binary Ninja from the command line, and if it will like spit out any debug information, and then we can like see what's happening. I'm pretty sure it's working. It's still not execute from there. All right, sorry about that. So we don't have log data. I'm pretty sure it's just crashing because the plugin's crashing. And I mean, it could be crashing for any number of reasons. Like any one of these like these methods could be getting called, and they're gonna lead to a panic. So I don't see anything here that like is just like clearly wrong, or that like would clearly be getting called immediately. But you know, who knows? I just okay. So it looks like there are flags we can give it. Oh, this isn't something stupid like value expression following the forward. That's interesting. So that doesn't work. Windows. Linux. That's so weird that the flag doesn't exist in here. You'd think it would still exist, even though it's like not the Linux one. Unexpected token or statement. And I guess I could try going into Victor 35. I mean, it is trying to start. So we're able to at least do the debug flags here. Standard log. That's so interesting that it's not. So dl log file.txt. It seems like it's not writing it out. Did it? Maybe it is this way. That's interesting. There's no log file being created. We can go into Task Manager and maybe watch it starting the process. It doesn't update. It's interesting that it's not. I mean, I gotta go find the directory. Yeah, here. I mean, we can. Is it RM on Windows, or is it remove, or del? So that starts. The other thing we can do is maybe we're getting a collision because we have two modules named msp430. So we can try getting rid of the other one. Actually, you know what we can do? We'll not do that. We're going to do this. We're going to call it something else. Build. And did I get that? Okay, fine. Source, GitHub. Copy it. Yeah, so that just dies. So something is clearly breaking it in here, but I don't have logs, and that's the problem. can try not registering it. But it's an architecture. Basically, this should still work. Yeah, so this does get loaded. We see. That's interesting. It does it by. It loads it by the name of the DLL. It looks like. Which that makes sense. It wouldn't know the name of it before anyway. Okay, so. Let's see what register architecture does. It does a whole bunch. It does an architecture builder. Like this. We could bring this back down to trace, but I don't feel like we're gonna make any difference here in terms of like R logging. I mean, like all of these shouldn't be called until after it has it's been loaded. Like it loads a file. You can see what happens up here. I mean, these are all unreachable as well. None of these return anything. There's no lifter stuff here, which is fine. Yeah, this is all decoding. LLIL. There is none for dwarf, I guess, or the thing just isn't done yet. Maybe it's the registers all. We can go in and we can stub some of these out with better values rather than unimplemented. Registers system. Yeah, I mean we can just put vectors in here, and at least these are. we already have this implemented? Yeah. Match ID 0 to 15 register new. Oh, that's correct. Flag from ID, we can make these none. This can be none. That can be none. That can be none. This can be none. Let's try rebuilding this. Function or associate item not found register. We defined register, didn't we? We don't have a new simple register. Okay, that's fine. Let's go, this is back in already. So, we should be able to copy this over. Does this start up now? It does. Okay. It loaded the module. So yeah, it definitely was just one of those functions that were unimplemented, and it was panicking and bringing down Binary Ninja. That's interesting though that there's nothing to stop it from taking down the whole program. It's kind of it's kind of cool, but I mean, some sandboxing would be cool. Let's open something. Yeah. So it shows up. What happens if we... Okay. Unable to restore architecture ID mappings. Analysis results may be improved by adding sections with the read-only code, blah, blah, blah. Okay. So I think it can't do anything because, like, basically we're always just telling it that it gets, like, 0 instructions back. That's good. So here's my other question is if we go back and make this just msp430, will they collide, and what happens when they collide? They do collide. Key error R15. Okay, so yeah, it seems like it's not happy, which is fine. Let's go ahead and remove the msp430 plugin. Uninstall it. I guess we'll leave it installed and we'll just disable it. Yeah. So say we load this, we make an msp430. Architecture ID mappings. Kind of curious what that means. No, nothing there. Okay. I think we saw these in the Python one as well, and I wasn't sure what it meant. Sorry, one sec. So this is all fine. We got a few things we need to do. The first is we need to make a calling convention, and there's two calling conventions for msp430. There's a stack-based calling convention and there's a register-based calling convention. So I think it's in a different file. Yeah, calling convention. So we need to basically build some implements this trait. Struct stack calling convention. The thing I want to see if they have actual names. They were, I mean, other than stack. This is the default calling convention. So impl connection. code's getting pretty messy. Probably some refactoring once we get all the stuff registered and kind of start moving stuff around. But for now, this is probably fine. Expected trait found struct. What? Why would you expect a trait? Wait. That's bizarre. It's not a... Is there a struct? There is one. Okay. Maybe we don't need structs. Maybe we can use the builder. Calling convention builder. New. Register defaults. Okay. Oh, come on. All right, so we have a few things we need to implement here. Oh, there's so many methods here. So we want to back to the Rust docs. Yeah. Give me like an HTML file. We'll work our way back to it. There. All right. Calling convention, builder. So, of course, there's an documentation for any of these. So msp430. Registers are passed starting with R15 and descending to R12, for example. If two registers are passed, the first is passed in R15, the second is passed in R14. In contrast, the msp430 EABI specifies that arguments are passed beginning hold two arguments. If two, I wonder when the EABI is used. Register 11 is considered a save or entry register. It needs to be saved and restored by the callee. If it's used in the called function, conversely, the msp430 ABI save call. So there should be a return. msp430 GCC and the GCC compiler for MSP use different registers for the return value. MSP GCC places the return value in R15 or R15 and consecutive lower registers if the value is larger than a word, while the EABI specifies that the return value is placed in R12. So here. Yep. Sets SP GCC and EABI. Prior to release 4.0 of TI's msp430 compiler tools, the one and only ABI for the msp430 was the original COF-based ABI. It was strictly a bare metal ABI, and there was no execution level component. Release 4 of the TI compiler tools introduced a new ABI called msp430 EABI. It's based on the ELF object file format. It's derived from industry standard modules, blah, 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 blah. Don't care. Calling conventions. A function call is made by calling dedicated call instruction, pushes the return address to the function on the stack, and branches to the called function. The function returns by executing a dedicated return instruction, which pops the return address from the stack. That doesn't matter. Register conventions, okay. Perfect. Okay. Argument registers. 4 of the general purpose registers are used to pass arguments to functions for msp430 and msp430x. The argument registers are R12 through R15. For certain special cases, R8 and R11 are also used to pass arguments. The number of arguments passed in registers depends on the size and type of each argument. Arguments are assigned in declared order to the first available register. Single pair or quad from the following list into which it fits. For msp430 and msp430x, the argument registers are 12, 13, 14, and 15. The size of the CPU registers is different on each architecture. The way the argument registers are used differs accordingly. Okay, so that's interesting. So if we go back, in MSP GCC, registers are passed starting with R15 and descending to R12. If the two integers are passed, the first in R15. Okay. So it looks like we'll probably want to support MSP GCC because that's going to be used for microcorruption. But if you were to look like a real firmware, then it would not be the same. It would be backwards. We may need to introduce some calling conventions here. APIs, MSP GCCs. Some differences between the eAPI calling convention. Though GCC has since added support eAPI according to that. So aligning with the MSP eAPI requires breaking compatibility with the prior. So yeah, the eAPI is the newer one, and I wonder what uses it. This is from 2015. We may need to introduce additional calling conventions here according to support. Seems appears to be a legacy calling convention, while eAPI is the newer standardized one. TI's all right, so the stack. So register. So caller saved registers, int arg registers. Great, it's just a macro that's not going to expand in here. Let's look at Josh's module and see what he does. Okay, so yeah, so he does int arg regs, and so it is just strings. So R15. Yeah, that works. Int R15 high. That's R14 and then register. Let's see what calling convention he is. Shit. Yeah, there's not documentation here, unfortunately. Basically, I don't know. I don't know how to handle the stack-based stuff. So if you look here, there's stack adjusted on return, and I'm not sure if stack adjusted on return means that it will auto clean up the registers, or if it will. I guess we don't have to worry about the return address here, because ret will automatically handle that, I think. Although stack adjusted on return. So like, do we have access to that? Is that a thing that we can do? True? Like, I would assume we want this to be true because like ret should make the stack pointer pop off the return address. Stack reserved for that's the thing we can do is we can go to the blog here and go back to that plugins. Where does it do calling? That's interesting. They don't do a calling convention for this. How's there no calling convention? Maybe it's in here. No? How is there no calling convention? That doesn't make sense. Yeah, it looks like it just doesn't define a calling convention. That's so weird. Alright. We can go look at the other ones, I guess. Yeah. I don't know if ARM to know the right calling convention there, but we can look at Linux. This is platform Linux. We want ARC x86. And I think it'll be here. Okay. Calling convention. Adjusted. So this is standard call. Does this have the 64-bit as well or not? ARM64. Yeah, this is okay. That's interesting that they don't have the. I wonder if it's in the platform Linux, and they registered a calling convention in there. Yeah, okay. So stack. No? Register fast call calling convention. Linux syscall. Where's Yeah, but where are these defined? These are defined somewhere else? Does the the 86502 have a? Yeah, like None of these have calling conventions. That's so weird. I mean, okay, so yeah, here's the fast call definition. Is there like a 64 in here? Yeah, okay. This is what we want. System 5 calling convention. All right. So that's fine. Hit call these saved registers. Does it adjust the stack? Like any of these have adjust the stack on return? Just this is it's only one of them, and it's only for the x64 Windows calling convention. Get integer return value. I don't know. I guess we'll get rid of this right now. And then stack. In CDECL, arguments are pushed onto the stack in reverse order. The caller clears the stack, and the result is returned via the process registry. The caller doesn't clear the stack. The callee does. Okay, so good question. I don't know what the calling convention is for this. What is Josh using? Return. So, I mean, that's registered. So we have our calling conventions in here now. We can build this. copy that over. I'm not sure if this is msp430 code or not, but that's interesting. That's kind of cool. I guess that's what you do is you build platforms on top of these as a abstraction layer, and that adds like calling conventions and stuff to it. Address 0 is not backed by the file. That's interesting. Architecture ID mappings. Is there anything for an architecture ID? Flag from ID. So, instruction info. So we aren't producing any text, but we are decoding stuff though. We still don't know what instruction alignment values are correct here. And this might be 2 and not 0. Like I don't know if it's like what the alignment has to be on, because we saw it being used as 1. You know what? There's a AVR, and AVR will have a 16-bit alignment as well. Max instruction. Yeah, okay, so it should be 2. Instruction alignment is 2. So we're not going to get data out of this right now. I guess we can figure out if this is getting called. Unused import. We have log. Yeah, okay. That's interesting. Why is it starting at 258? How many bytes are there? It's 160. Yeah, so 258. Why would it start at 102? I mean, that's like over here. That's interesting that it's starting so far into it. Exercise. Assertion text. Is this something? I mean, I can back up the Chernobyl database, and I can load that in. Yeah, let's do that, because at least we know that that's correct. Yeah, Chernobyl.bin. Again, starting at 258. That's so weird. Oh, okay, so here. It called instruction for 0. And text. I wonder if it gets the decode first, and then it goes back and tries to get the text for it once it figures out whether or not it got something decoded there. I'm gonna go ahead and close this. Copy that over. Instruction info. Yeah, so it's never calling. I wonder if it's getting so I wonder if we're ever getting in here. interesting that it's never getting a valid instruction. What we can do is we can grab 2 bytes out of it. Data adder slice indices are of type usize or ranges of usize. Not a function. Found macro log info. Oh. What? I wonder if that didn't work before. All right, so that crashed. That's fine. We probably should get a working debugger set up going at some point. So it's never getting a valid instruction, which is interesting. I wonder why that's the case. We can get rid of this and just do data adder. I would assume that it wouldn't go into a position that's that's out of range. No, it crashed. I don't know why. So that's so interesting that I wonder if we can just do this and do like this is gonna be massive if it actually prints it, but oh, that's interesting. So it only gives it 3 bytes, which is not enough. Okay, I see what the problem is. We defined this as 3, but it should be 3 words, so it'll be 6. Instructional alignment is 2. I think that this is going to end up being Oh, yeah, so it's finding valid instructions now. That's perfect. So how many instructions are we actually finding? I guess that's like the question is we want to know. Found 2. Here's my concern. The address that's getting passed in here is increasing, but the view that we're passing is not. And I'm willing to bet that the problem is that this address is far beyond what is in here. Let's get the error. I bet we're going to see a whole bunch of out of range. Mismatch types. Come on. All right. So let's see all the errors now. I'm guessing they're going to be out of bounds. Like the address we're looking at is just far beyond what the range is that we're getting given here. Not enough data to decode instruction. Yep. So that's interesting. Why is it instruction info? I wonder if I can print the instruction info here. Does it not have display? Is it debug? Of course it's not debug. How do you not implement debug? So are we getting the right values, I guess, is the real question here. first one's 4 bytes, which I don't know what the instruction is. I guess we could decode it manually. Just 40. Yeah, so this is let's decode this. 40, 31, 44, 00. msp430 instruction coding. That's not what I wanted. I wanted this. All right. 0, 1, 0, 0, 0, 1, 0. So move instruction. Source is 0, so that's PC. AD is 0, so that's a register direct, which we expect because it's PC. PW is also 0, so it's 16-bit, which is what we want. AS is 1, 1. And the register is destination. 1. Interesting. So the source is so that's 0. So the addressing mode, if it's PC, the addressing mode would be 2 bits here, so 1, 1. It's immediate. Okay. So next word, which is 4400, and it goes into 1. So AD. What's 0? Into register. Register 1. Okay. I wonder if it sets up the stack or something too. Either way, yeah. So that's correct. And then was it 4215? It's 0, 1, 0, 0. Source is 2. AD is 0. Register direct. PW is 0. 0, 1. The source is 1. Addressing mode is 1. Is indexed. Are we returning things in terms of words or bytes for length? It's a good question. We're doing it in terms of bytes, so that's correct. That's fine. Okay. msp44215. Actually, you know, we can just log in. Give me a second to switch off the I just want to log in while I'm on stream. But give me 1 second. We can just go look this up. Like, we know what it does. Like, we have a source of truth. All right. Let's switch this back. Disassemble that. Fine, Chernobyl. Yeah, so if we go up to here. So 43.1, 44. Yeah, okay. So that's at 4,400. Yeah, they're both moves. Yeah, okay. So that is correct. So what I don't understand is why the address here constantly increases. Like, maybe that's not for us to index into, but it's just maybe that's so you're aware of where you're at, but not necessarily, because like it's windowing our data for us, and so we might want to go and change our implementation here. How big of a change is this for us? Maybe not too bad then. So, say we get rid of this. This is gonna suck for all of our tests that all have these in here. But say we do that. What ends up changing here? It's less than 2. So this becomes data split at. We're gonna match data 0. All right. So let's rebuild this. Let's rebuild this, and we need to make one small change to here, and that is we don't pass this anymore. And we should get a lot more instructions now. I gotta kill this. And back to here. That's pretty good. Holy shit, it's working. We can even do this. We can even verify our disassembly is correct. Instruction. Inst. So, yeah. So that's correct. Printing is slightly wrong here, but everything else is correct. That's correct. Yeah. Here, we can make this a little bit easier. There. You know what? Let's actually start this at 4400 so that our addresses line up. Cause that works. Image address base. So our first error occurs at 4566. 4, 5, 6. Yeah, it is. It's a word. It doesn't decode. That's interesting. So it does get off though. BRPC. Why does it think that ret is a BRPC? Where's the previous ret that we can go look at? Like, are all rets that way? Oh no, there is a BRPC. We just missed the ret? It's interesting. 4, 5, 6, 4. Five 60 is a pop R10. 6-2. Pop R11. 4, 5, 6, 4. So that's so weird. And then it does the sub C. So it misses the ret for some reason. I mean, that's all fine. The next ret is at like 465C. .465C. Yeah, it looks like it's not handling rets properly. Is ret an emulated instruction? Oh, it probably is. It is, okay. Yeah, so we're not handling rets properly. That makes sense. So that'd be 2 operand move. So if the source oh, yeah, okay, so if the source is yeah, so if it's not auto increment, the destination is I think that ends up being correct. We don't have tests against our printing, unfortunately, but I think that probably doesn't matter. Let's copy this over and try this one more time. It's pretty amazing that like it's all just kind of working. Like that was like really like one issue we saw. Yeah, so our rets are coming in now. That's correct. So 4566. Yeah, so that's correct. So it rets, and then there's a push R10. I don't know why there's a push R10. So we get that. We get the ret. Oh, so we're the push shouldn't be. So if this, like, what's compatible with a branch? Oh yeah, no. So this is possible inside here. So how do you differentiate between? How do you differentiate between a ret and a BR? A ret is there and a BR is. The BRPC is gone. what is this supposed to be, I guess? So, is it 465E? So we get the ret add CB, so R5 to R8, and then so we're missing the sub C. That's failing. So source addressing mode is 2 for register 0. Oh yeah, there is no addressing mode 2 for PC. That's 100% right. Like I wonder if the intent is that this inherits from here but overrides 0, 1, and 1, 1. Because it's indirect PC. Is that 2 for this? Yeah, so it must be. It must be that these are just the changes and not that. Okay. All right. All right. I think I'm gonna wrap up for the day. We got a ton of progress done. We have the module loading in. It's showing up as an actual plugin for Binary Ninja. We have it decoding. We figured out a few different things about this. I need to take some notes down about stuff that needs to get fixed. Let's see here. Before we wrap up, ret may not be handled correctly. So we found that ret is not working properly potentially, and how do you differentiate between pop and BR? So those are two of them. The label is not printed correctly. I think we figured out. All right. Move. Yeah. So that's another one. Fixing. See. I think that's it. I mean, I think once we get those in, we should see like basically these issues go away, and we'll have basically correct disassembly. And then we can start building our token stream. And the token stream, I think, is pretty straightforward. That's interesting. So, oh, PC, yeah, because it is 0. That makes sense. Clear's not working either, it looks like. CLR. It's interesting. Test R13, JC. Huh. I wonder why it thinks that's B and not something else. Yeah. Anyway, I'm gonna wrap up for the day. Hope you all enjoyed this. Hope you all got something out of it. I know I did. I'll see you all maybe tomorrow, but probably next week, and we can. I'm probably gonna fix all these things off stream. Just get them going, and some of the hacky stuff done, so that when we get going next time, we can basically start implementing the token stream. And that'll let us get like real disassembly in here to the point where we can actually start looking at like stuff. Anyway, have a good night, everyone. Good day.